Hi, and welcome to Tremco Live, where we're socially distant but technically connected. I am Marcy Tyler, the Director of Building Science for Tremco, and I am one of your hosts.
And I am Paul Hugenboom. I'm your other host, and I'm the president of Tremco Construction Products Group. A fantastic collection, Marcy, of brands, companies, products, systems, and of course, most of all, people all over the world.
Most of all, people. I'm glad you guys are all here today, checking in with us on our final Friday in June, but you're not going to want to miss next Friday because we're going to feature a lot of those people that Paul mentions every time we kick off our broadcast. So definitely check out our July 2nd broadcast because we're, like I said, going to feature a lot of those people.
Yeah, our feet in the street, or expression I use a lot, belly to belly.
Yep.
Of course, we can, I guess it was mask to mask for the last year.
Yes.
Well, we're
Yeah.
looking at masks.
Masks and 6 feet.
That is the foundation of what sets us apart.
It is. It's so important to us. So if you've been staying in touch with us throughout the month of June, we're talking all about testing. So we kicked it off, Paul, beginning of June over at the test facility, kind of walking everybody through what we got going over there. We've had some great guests come on, talk to us about different types of field tests. And I thought it would be interesting for us today to feature something that seems to be the most common question we get at the test facility in particular. Is all about how do we properly detail fasteners. That seems to be the biggest question that we get.
And I think the thing, Marcy, you always say that it's really the, what do you call it? It's the paradox. We seek to have continuous integrity of membranes and put a lot of fasteners through them.
Exactly. So, and it's pretty exciting because as we have been communicating with people on a regular basis, the conversation is going there. So maybe something that we aspire to get to in terms of that understanding about you're going to take all this time, effort, and energy, put something down, and then you're going to poke a bunch of holes in it. People are paying attention to that now, and they're getting upset when that's happening. So we're definitely getting there in terms of that awareness.
Yeah, and it's just an interesting paradox, right, about how buildings are designed and how they're constructed. So bringing a lot of awareness to why are you penetrating at all, and if you're going to penetrate, well, how much,
Exactly.
how many,
exactly,
and are there good, better, there's a lot, you've taught me over the years, there's a lot of counterintuitive things about what the naked eye sees versus what empirical data shows.
Absolutely. And I think that's, thank you to you, Paul, for your investment and, support of our test facility, because it's given us that ability to do just that. Take what we thought was maybe the condition or the concern and test the heck out of it. And come up with some things, like you said, that might have been counterintuitive in terms of performance.
Yeah, and the other thing we find a lot, because we drive with about 8 inches of water, is it a minute or an hour?
For 8 inches of rain per hour.
Oh, per hour. Yeah. A minute would be a lot. But that when you get that continuous film of water and you've got interesting things going on with building pressure, that's when some interesting results show up.
And people will argue that, like, why are you doing it to that level? There's going to be a facade in front of it. And I think what we like to do is just test for, an extreme condition, because this stuff's behind a facade, right? We're not giving you a maintenance plan on these products. So we need to make sure that we're doing it right and doing it right the first time.
I think the other thing is they're called 100-year events, but they seem to happen every year now, right? I think as the weather has gotten perhaps more volatile, or you see more extremes. So I think this notion of a 100-year event is probably, literally might be an annual event at this point. So it's become real important.
It is. It definitely is. Here we're just featuring a bunch of pictures of studies, looking at different types of anchors, looking at different types of insulation pins, looking at panelized solutions, putting in that real window into some of these mock-ups. I think the bottom one, you can't see all of it, but I think that's one of your favorite mock-ups that you liked seeing there. So we tried to put in one mock-up a variety of different types of ways of anchors and mechanisms. You got blind fasteners, you got fasteners you can see. All of those things are what we like to be able to look at before it gets to the job site, just to give you that background as much as we can identify.
Yeah, I think the trend in panelization is only going to make this topic that much more important.
Absolutely. And, you know, I put this question up there, you know, what do you think is the most requested test? And I already gave it away because it's fasteners. So, and a common question we get, you know, hey, I want to take a look at a certain fastener. Just go ahead and email me or your Tremco sales representative. We might have already done it because, Paul, we've been doing this for quite a while now. We've got a great library of information. People always want us to produce that library, and it's not that we don't want to share. It's just that we'd rather have that conversation with you on your specific condition, right? If you're a 12-story building versus a 3-story building versus being on the coastline versus, you know, what kind of insulation are you using? There's so many factors versus just telling you, you know, hey, we did this threaded fastener or this type or brand of mechanical attachment.
Right. The other thing we see, Marcy, there's often what I call vigorous debate on different points of view. And the thing I like about what we do is no need to debate it. Let's just put it up on a wall, and let's just see what the data shows us.
Absolutely. So my call to action here, as you guys are listening to us today, tell us what you want to see. Tell us what anchor you want to see. Some people want to follow the test method according to the certain air pressurization, the pressure differential, excuse me, that is required of these tests. Some want to go for a longer duration. Some want to go for a higher, not so much a longer duration, but a higher pressure differential than you would typically see. Let us know what you want to see. Let's take a look at it. There's been a lot of information that we've been able to generate that's out there and more to come. And this is just a few things. You know, I wrote a Façade Anchor paper a long time ago. I think it was 2016 when I was with Matt Reisinger at the Building Science Camp, and we were talking all about nail sealability. Our buddy Corey just wrote something in September of last year all about it. So there's a lot of conversation that we like having. But I think what's most important, it's not what we're thinking. You know, we want to know what your questions are and what your input could be. And I think this is a perfect time for us to bring on our guests today.
Fantastic.
So let's invite and welcome the Keiths, Keith Squared, Keith Simon and Keith Nelson. There you go. Hi, guys.
Hello, hello.
You both have been on Tremco Live before, so welcome back. Welcome back. Thanks for coming on. If you guys didn't catch Keith Nelson the first time, he talked all about the burning questions about fire and specifically NFPA 285. And Keith Simon talked to us all about those misperceptions about EIFS. And my favorite thing was about a naked building and a closed building.
Yeah, we've stolen that.
Yeah. We give them credit.
We give them credit,
Yeah.
but we're using it liberally.
Yes, we are. Look for that new marketing campaign that comes out. Maybe we'll put your picture in there somewhere, Keith. I don't know.
Hopefully on the closed tab.
Yeah. Yeah, maybe you don't want to be associated with it. Welcome, guys. We know there's a lot of conversation around just even the test, nail sealability. So let's go through this and have a conversation here. So first of all, I always like sharing this. You guys see this on a regular basis, right? The picture on the left, great, right? We've got somebody did a great job doing all the air barrier installation, but then you can see the insulation's being hung, right? And then we've got a different type of clips there in the middle picture. But what we don't want to see happen is we certainly don't want this to happen to the air barrier.
Right.
So,
Yeah.
So Keith Simon, Keith Nelson, tell me what you guys think. We'll start with Keith Nelson. What do you think when you think about nail sealability?
Well, the first thing I think about, especially going to this question, what happens when facade anchors are installed? We don't always hit the stud. And so not only is it a discussion, which is the focus today, of what happens with that fastener penetration at the WRB, but also from a quality controls perspective, how are we dealing with those misses and not getting into the studs or whatever structural support is behind there? And we're dealing with that quality control aspect. But I would say what happens when a facade anchors are installed, and we are effectively poking holes in the WRB, the water control layer, the primary water control layer, and the air layer. And we want to be cognizant of that and making sure that we're putting other systems in place that will ensure that we're not impacting the overall performance. I mean, if you think about it on an isolated basis, a single fastener isn't a massive hole, but if you look at that photo, there's 2 fasteners in each one of those clips. It becomes a pretty large hole pretty quick if you haven't dealt with it. And just because you see pookie on the fastener doesn't mean it's actually sealed. And I think we get into that a little bit later here.
Yep, absolutely. Keith, Simon, what are your thoughts?
Yeah, so just to keep it in perspective, I think a lot of people wonder, well, how come I can literally poke thousands of holes in my air barrier and it doesn't fail, right? Because if you look at that, there's just like holes all over that thing. And so it's important to remember that on walls, gravity is on our side. That usually when you have a fastener, even if it's a fastener that worst case scenario gets pulled on, you actually have a hole, most of the time, the gravity is going to help us out and it's not going to go into your building. It's just going to drop down and it's going to be okay. The problem starts to come in when we accidentally introduce things like pressure differentials that could suck moisture through, or the introduction of hydrostatic pressure, right, water buildup. So, you know, let's say you have a Z-gird that's accidentally installed upside down and actually holds water against a fastener. Now you have buildup of hydrostatic head or hydrostatic pressure that can force that water through. And then there's a lot of things on buildings that add risk, right? So if you have a low rise, wood frame, wood sheathing, wood studs, you're a very low risk. But then you start going taller and you get higher pressure differentials. Maybe you have gypsum sheathing and metal studs, and you're trying to hit a metal stud and it's a lot harder than hitting a wood stud, or you hit gypsum and it moves around and creates a bigger hole. So there's all these factors that start increasing risk. And so the really tricky thing is, do we have a project where we can't allow that kind of risk, or we can handle that kind of risk, and what kind of detailing is appropriate? And it can get pretty tricky pretty fast.
Absolutely. I think those are great points from you guys. And I think that's important, and is why we've done a lot of fastener testing, and that's why we don't say, hey, here's your library of tests, because there is so many factors. And in some instances, you know, how great of an impact could it have? You know, we always like to say, if you're putting a fastener in and you miss the stud, leave it. You know, don't take it out, at least leave it in place if you can. I'm sure you guys all have pictures maybe of multiple fasteners being left in place all over the place. So that's what I would love to see too, you know, people that have seen some issues. I think we all understand the importance of them and why they're there, right? They're there to hold back the cladding and provide that structural element of that exterior facade. So not only are we going to be putting these penetrating items into our weather resistant barrier, air barrier, our waterproofing above grade, we are going to put a weight on it too. So that's another factor that we don't always get the chance to take a look at. And I think that's why we like to kind of test to extremes to see. But that's another factor, right? You know, what's going to be hanging off of that structure.
Yeah. Well, and just building on that too, if I may, is that, and to what Keith, the other Keith, the first Keith Prime said.
The other Keith.
Is that there are many factors that we're looking at, and I love the discussion about risk and understanding what the risk profile is for the specific project, because not all projects are the same. But then also understanding, and I'll credit Dirk Meyer with this, but when we test these products either in the lab or even in new construction, we're testing these products at the best they will ever perform. Once they're installed, there's temperature fluctuation, the building moves, there's other construction activities happen from the installation before the building's complete. And so just understanding that while it may seem extreme to test something to, 15 pounds of pressure for 15 minutes, it's not necessarily that we're saying it's going to see that kind of a force on the fastener or on the system itself, but that extra pressure and that extra duration is a proxy for the degradation of that performance that we may see over time, to make sure that we have something that will last the life of the building and we have something that is durable.
Exactly. Well, and I think that's what's important at the bench scale testing or at our test facility testing is we're just trying to highlight those areas of concern. Where could a potential risk occur? Mm-hmm. What's that mode of failure that we could be looking at, and what's the fix?
Yeah, and I think Keith, I'm going to defer to.
It's easy, just say Keith.
Which Keith?
Yeah.
But Keith just made a great point about this testing something in the best conditions it'll ever see, and I think Marcy we are always pushing ourselves to say, let's try to figure out what the worst conditions could be for exactly the point that was just made, right? Because what we're looking for is what's the mode of failure. And I think over the last couple of years, especially, Marcy, it's been eye-opening that we've uncovered new test methods that get us to a new worst behavior,
Yep.
precisely because we weren't getting to what was happening in the field, right? We had to do, for lack of a better word, worse.
Yeah. I know we spent a lot of time and a great future segment about roofing and some of the innovative approach we're taking there in terms of testing in the worst case situation so that we can overcome.
We keep looking for worse tests.
Yeah.
That's a technical term, Keith and Keith.
Yeah. Well, and I think everyone tries to refer to this test, the ASTM D197, which is the 70, specifically section 8.9, which might be debatable. Some people say section 7.9, so I think it depends on which one you're looking at. But this is not about an air barrier product, right? Because it involves a smooth roofing nail if you're actually following the test method. And it's all about nail sealability. So you've got your 5-inch head of water, you've got your smooth roofing nail, you got to back it out, and it's in plywood. So we're not including any kind of framing. So framing is going to give you an extra level of support if you're using sheathing, if you're using block, all of those different things are going to be a factor. And of course, you got to get your threaded fastener in there. Keith, I'll ask Keith Simon first this question. Do you hear people say, is it self-gasket, self-heal, or self-seal?
Yeah, we hear those terms a lot. Like self-sealing is one you hear a lot, and self-sealing really doesn't happen a lot in our industry. There are some times, like I've heard about like zinc, you scratch it, actually self-seals over time, or like, I don't know, maybe like a self-leveling sealant, maybe there's one. But like generally what we're talking about here with air and water resistant barriers, that self-sealing, that take that off the table, that doesn't really happen. But there is something called self-gasketing or sealability, which I think are reasonable terms. And that has to do with the ability of, like we're talking about, when a fastener or an anchor goes through the membrane, how much does it gasket and kind of plug that hole? And there are some good rules of thumb out there that we should all know about. And the thickness of the membrane is a big one that, it's not 1-to-1, it's not 100%, but like in general, the thicker the membrane, the much more significantly it can plug up that hole. So that's one of the things we fight most for in specs and in design reviews, because there's a lot of fluid applied air and water resistant membranes on the market that we categorize as thin mill. The dry film thickness, once it's installed, is like 6.5 mils. I mean, that's thinner than paper thin. And like, if everything's installed perfectly, it'll work. But there's no room for error. There's no room for building movement. There's no room for it to bridge cracks. And so we see a lot of failures on projects that use these thin mills. So then there's the mid mills that are maybe like 10 to 20 or 30, or the thick mill ones that are more like 30 to 40 mils. So we're really pushing to add have on a job those thicker membranes. And frankly, if we get like 20 mil dry film thickness or more, we're psyched. But if we can get the 30 or 40 ones, and nothing's a silver bullet. It's not like you can install a thick membrane and you're just good to go. Those can be installed incorrectly and have problems too. But we're talking about risk, and just the risk on the project goes down significantly when you have a thicker membrane. Is there a cost increase to go to a thicker one? Yes, of course there are, but the amount of cost on the project in terms of balancing risk reduction versus cost, that one's an easy sell in my opinion.
Yeah, well, and if I can tie back to my previous discussion too, the other challenge is as you go to thick mills, which I completely agree with. I'm going to go with Keith Prime. Keith Prime said that then you increase your requirement to now comply with, likely, if you meet the requirements, non-combustible building over 40 feet tall. Now you're going into 285 territory, and you're getting out of the products that will generally meet that exception. And so just understanding, as with everything in our buildings, it's not a myopic view of, yeah, I've got nail sealability. You've got to look at how it fits into the whole picture of the project, as Keith said, with the risk profile and what the project is actually trying to achieve. There's a lot of moving parts. There's not a silver bullet. There's not one right answer. But yeah, as long as we're not talking about self-healing, that's the word that makes me cringe.
Yeah.
Unless we're doing a coal tar roof, I don't want to hear that.
Yeah, exactly. I go for the self-gasketing as well.
Right.
We like to promote, I think whenever you talk about modifying a test, I think people cringe, right? I like to say modify it in a good way, right? Yeah. So take that nail sealability test, use your threaded fasteners. Hopefully you don't get what's going on there. Now that was a thick membrane that wasn't reacting very well to that type of threaded fastener. But I think it's important to get that level of understanding when you're putting in these threaded fasteners, you know, what is that membrane going to do or not do to protect you, at least at that level. So I think that's super important to take a look at. We also like to put different types of indicators in the water so we can bust open that substrate afterwards, because maybe we didn't see it drip down the fastener, but maybe it's absorbed within that substrate some way or somehow. And you know, this is super technical here. We break open a highlighter, Paul. They put it in the water. It works. It works. What do you guys think about, you know, doing some of these modifications? And this is obviously at the material level.
Well, so I'll go back to the comment I made before. Some people might look at this and say, well, it's just a little bit of moisture inside the sheathing itself. You didn't see it on the inside, so why do you care? Well, again, over time, that's going to be a much larger issue, and you're going to have sheathing and potential structural degradation and degradation of the fastener and all kinds of other challenges that come with that. And so while this may seem, you know, minor on kind of the bench test method, if you put that into the lifespan of a project, it is a very significant factor, or can be.
We've also just taken a look at just materials themselves, right? So without even any penetrating item, just to kind of see how they fare. This is a hydrostatic head test. So nail sealability, we stole that from the roofing spec. This one's from the textile industry. But just once again, you know, just taking some extra time to put some broken up highlighters into your water, just kind of gives you that understanding. And just like you said, Keith Nelson, you know, it all depends on what type of project you're looking at, what kind of concerns you might have, how quickly the moisture got into that substrate, and you know where you're building this and how much of a concern it would be. We just like to kind of understand that once again, just be able to highlight points of concerns we might have at that material level.
Yeah, and so it's probably, I'm glad you're bringing up these tests, the D1970 and the ATTC, from the textile industry, as these are sort of what's out there and then we're modifying, but it's important to recognize that the industry is so badly in need of a test method for walls, because walls don't behave like these textiles and roofs, right? Roofs is horizontal, it's a nail that's backed out. It's not the same thing. All the laws of physics are completely different on a wall. And so we have these tests in our spec and it passes or fails. Is that good? I guess it's a good indication, but it's not exactly the same thing. And if it fails, is that bad? Maybe, not really, because like the textile one, 24 inches of head. I mean, that hydrostatic pressure, that's insane. We should never see that on a wall. And so I know that I love what you guys are doing in the Tremco testing lab, trying to modify these test methods and find out something that's more accurate. And I know the Air Barrier Association of America is working really hard on finding a test method that can be used on project-specific basis. And one of the things I know that they're struggling with is, what are the right detection methods, right? Like, is it okay just to look at the backside of the sheathing, which, you know, Keith Squared pointed out is really insufficient? Or if we're in the field, can we use water detection paper, or do we need to use relative humidity probes that may be readily available in a lab but harder to, you know, have on a test site? So figuring out all of these things and trying to standardize them is something our industry is kind of badly in need of right now.
Yeah, and just to tag onto that real quick, I mean, just you could have a whole other session on just defining what is water leakage.
Yes. we could talk about all this stuff for hours and hours, and we have.
Yes.
Well, and I'm glad you guys mentioned, ABAA, they've gone through and they're actually currently looking at the adhesion standard, which is ASTM D4541. They've made some recommendations on that, and they're currently accepting comments right now. So that's something to look for if you guys are listening and want to contribute to there. And then they also are looking at nail sealability as well. So those are future things coming where we can all get together and talk about them. And try to define that further. I think a way that the whole industry, and obviously we do at our test facility, is embracing ASTM E331. So now we're looking at it at least in a wall configuration, where I think Keith Simon, you mentioned, gravity is working in our favor here. Once again, we're putting a lot of water on that face because we're trying to get that continuous film of water so that we can start to look at points of concern. And I think you also mentioned the upside down Ziegert, which is captured here as well.
Yeah, that's a good one.
So we like
Yeah,
that.
that little waterfall scares me more than the fasteners, but that's another discussion.
Yep, that's a crazy amount of water, and what we were trying to do is do the worst case, right? So we put them upside down. We know that's not the way they're going to be installed, but we're just trying to force a potential issue to rear its ugly head if we're going to do it. This was great.
That error done all the time. I mean, I've seen it on a job where they did them installed correctly all over the job, but then at the base of a window where they were trying to capture the cladding, they flipped one of them.
Yeah.
So it's a mistake that's done quite frequently.
Well, and windows aren't a vulnerable piece of the wall, so that's fine. I was going to. What? And do you get to 2357 at all in the slides?
I do not. Not.
So that would be just, looking at E331, yes, we're looking at wall, we're looking at a spray rack, we're looking at a pressure differential. It is about the film. It's not about the 8 inches per hour or whatever it may be. But what I would like to see for anyone at ASTM listening, and I do sit on those committees, is to see 2357 that has the structural loading, has the air test, put it through a thermal cycle, and then do a water test, just as an idea.
Well, and that's what we do. We do that, Keith, at our facility.
Several manufacturers do.
Yeah, we want to see 2357 first, and then we go ahead and do the water leakage. So we want to put it through that rigor, so then we can see if there's any issues that arise because of the 2357. So.
Well, and it's worth mentioning here too, I mean, we talk about the amount of water that's going on the WRB. Something we often hear in the field when we've spec'd testing prior to insulation and cladding is, well, we're never going to see that much water. It's not a fair test. If it fails now, it only matters if the cladding's on. So I hear you. One, it's not what you were asked to do, so we can have that contractual discussion. But then also, again, this is the best the system's ever going to perform. Our goal is to be able to test it, to make sure that it works, especially in an on-site, off-building mock-up, and test it without the cladding and insulation. So if there is an issue, we're not having to deconstruct the thing and potentially damage it to identify and address what the challenges are. So ultimately, we can learn from it and do it in a way that will perform as needed on the building itself. So it's not uncommon to see the projects tested without the claddings in place.
Yeah.
I think, Marcy, it's an interesting comment Keith just made about, oh, we're not going to see those conditions. My experience, especially the last couple of years, has been is that the tests are not difficult enough, right? It's been actually the opposite direction. And again, I mentioned it a few minutes ago, we're coming up with far more rigorous bad tests because of that. So I think we've been continuously surprised that we're not getting anywhere close to how bad it could get in the field, right? And again, I think it's just counterintuitive.
Yeah, absolutely. Well, and I put this up here. When I give our tours, we always have everyone watching answer, and I've done this before on Tremco Live, just to kind of say which one performed. We did do for this test. We did ASTM 2357. Then we went ahead and did the ASTM E331. We did it up to the 300 pascals of pressure, 6.24 PSF, and we did it for 2 hours. What do you guys think? And you may have seen this before, but what do you think? Do you think they passed at that level?
So all right. I'll just take a stab. I don't know. I'm so anxious to hear the results of this one. And ideally, I'd actually like to have number 1 in combination with 2. If I was, I would like to have both of those done. But if I had to pick one of these, I'm just going to take a stab at number 1 because I like how the top edge is sealed off, so it prevents the water from getting behind the clip and creating hydrostatic pressure behind there. But it could get sucked in through that hole and get it anyway, so I'm not sure I'm right on that.
Yeah, I think the 2 hours is probably the challenge to number 1. I was going with number 2 just for the gasketing, but I agree with Keith Prime that I would probably actually be looking for a combination of these.
So what we got there, I mean, you guys probably see it's orange membrane. So it's the Secure Export 430, right? That does well with gasketing for fasteners already. Then we went ahead and put these clip and rail systems in. They all passed at that 300 pascals.
Really?
All passed as we continue to ramp it up, all the way up to 1200 pascals without any failure. Now, number 2, as water kept coming down, the whole project team was here and present watching. They felt that over time, they were just worried about that top edge of the peel and stick. Yeah, and so they went with number 1. Now, in all honesty, number 1, that's a terrible detailing job. You might think more sealant, better? No, because that you could start to cause little nooks and crannies or little valleys. So we redid it with a nice thin bead, beautiful, and it passed. So the way this test was working at even at high pressure differential, I think because of the 430 with 20 mils of membrane, 1 was the way to go.
So actually, a quick question about the clips. Are those clips flat against the surface, or is it profiled so it's just the edges that are on the sheathing? You know, offhand?
It's just the edges. You can kind of see it's kind of got a little step out to it. Can you see that there? It's kind of hard to see, but you can see on the edges they're in contact, and then there's a bit of a gap.
This may sound weird, but I'm wondering if that third hole in the middle actually helped them some as far as relieving the suction behind the clip.
That's interesting.
What about, did you guys test with no detailing at all? Did it also pass with nothing, no detailing whatsoever?
Yes, it passed without any detailing. Yep.
Did you test it after someone weighing 250 pounds stepped on it first?
No.
Okay.
That's why. Well, it's funny because there is so many different things that you can consider, right? And I think that's why we like having that ability. And it would be fun actually to have you guys in and have us do some crazy things like that. Like, okay, you might have tested it like this, but now let's hit it with a hammer, or let's put a weight on it. Let's do that, or let's do that.
I think 3 is always the surprise to people, and it really speaks well to the ExoAir membrane. Right? Yeah. It does a nice job.
It does. It does.
Well, and worth saying here too, just sorry, real quick, is both of those fasteners are attached at the primary control layer, which is a critical distinction as far as versus having a rigid insulation that goes over it, and then you have an anchor that attaches at the outside of the insulation if the insulation isn't the primary air and water control layer. So now you've got a blind condition. Another interesting one to look at that I'm sure you have.
And we're going to feature it later in July because we're going to have Jason Wigboldy on. We did a lot of insulation fastening with his fastening mechanisms through insulation. And then it's interesting because we've done that with him, but then we've also done on job sites where they wanted to say, okay, I put the fastener in through the insulation, but I missed the stud. Now I'm going to take the fastener out. How do I need to detail it? And we've tested that too. So lots of different cool things that we can do. Or at least I think they're cool. ASTM 1186, how often do you guys see this being done in the field?
A lot.
Yeah, we do it. It's becoming more common, I think, actually.
Yeah. On roofs as well, but different discussion.
We were concerned, I think, with this test initially just because of the pressure differential that is being introduced on such a small area, but we bought the equipment. We talked to people like, not Keith, but Kevin Knight, to kind of talk to him about, I think he developed
It
this.
could be confusing.
So just kind of getting a comfort level about what we're looking at and why, and we have one here to be able to kind of experiment with. And I think our favorite thing to do with it is somebody made an installation in the field that maybe we didn't want to recommend or support, so then we try to mimic it and see what's worst case scenario, and that's what really helps us with this.
Yeah. Well, and the couple of things here. One is recognize that 1186 is not intended to be a pass-fail criteria. So that's the gut check comment at the bottom, or the qualitative test. However, it is sometimes written into spec as a pass-fail test. And if it is, then it's critical to understand what that pressure is. And I guess I try to keep people at the 75 pascals to mimic 2178 and 2357. But I know there are others that do higher pressures, just looking for those bubbles. And then the other concern too is some WRB manufacturers are also concerned about putting the surfactants on the membrane as well, especially if it's something that's going to stay in place. But
Yep.
things to be worked out.
One thing I'll add to that is, sometimes it's in the spec, we do the testing where it's like, okay, the membrane's been installed, test 20 locations.
Mm-hmm.
And there's a little bit of value in that, but I'm not crazy about using it in it because usually it all passes. It's no problem. So I think its real value is what you're showing in the photos here, where like you're testing the cladding attachment or a penetration or an awkward transition from one material to another, or I don't know, all these like particular unique things that need to be detailed. I think that's really where the value is with this test.
Well, and the one at the bottom looks like it's failing at the lap joint too, which is interesting.
Yeah.
Or showing signs of bubbles. Maybe not failing, sorry.
Yeah, signs of bubbles. And then just some other on-site testing, doing different types of spray rack tests. I think this is, what is this, AMA 501.1?
Yeah.
So different things that we can see, different things that we can do on site. I'm sure you guys have been a part of a lot of this type of testing as well.
Yeah, I mean, the 501.1 is often equated to 1105 because you are imparting a pressure differential across the specimen. It was written for fenestration products, but we are often applying it to opaque assemblies as well, especially on on-site off-building mock-ups and first installations. But yeah, I mean, it's another way of getting a pressure differential, a driving force, and getting water on the system. Difference being is it has turbulence, where 1105, especially if you use the static version, it's just a constant pressure for the 15 minutes. So maybe less of an issue on opaque assemblies, but when you're talking about fenestration products that may be gasketed, they can perform differently in those two tests.
Once again, we're pulling this from the fenestration, right? Trying to get some sort of understanding on performance. What do you guys think? So with this one, with 501.1, we're putting the fan pressurization, right? So we're putting a pressure from the outside onto the surface. When we're doing AST and E331, essentially we're putting water on the face and we're trying to pull it through.
Mm-hmm.
What do you guys think about that? Like the differences between those two?
Well, the E331 is your lab test, right? Whereas E1105 or 501.1 is more the field application of it, which is kind of industry standard for acceptance testing. And maybe if I could just quickly say, general categories of testing of acceptance versus diagnostic. So, acceptance, they're in the specs. It's been installed. You want to verify that it was installed as designed and expected, and hopefully it passes, and then it's kind of like test and verify. Diagnostic testing is more where we know there's a problem, we're trying to figure out what the problem is, and so a lot of times we'll modify the test method if it's diagnostic. So like Keith Squared was talking about putting the rack on an opaque wall assembly. Like that's a modification from the test standard, but if we're just trying to chase down a leak, we'll modify it however we want. And folks in the industry usually get that. If you call it diagnostic, it's kind of like, okay, you do what it takes to try to figure out what's going on. I remember on a litigation project, there was like this team of attorneys and expert witnesses, and the guy was doing AMA 501.2 testing, and he started to modify the test and do it in a way that different. And this team of experts just started like getting on his case and like, what are you doing? You're very, and he's like, oh, this is diagnostic testing. And then once he used that term diagnostic, everybody just backed off and said, oh, okay, yeah, no, I get it. And then it was quiet from then on. So.
I think that's important to be able to have that ability to find what was the cause, for sure. And last but not least here, this was sent in by somebody this week to say, you know, people here were trying to do what they thought was the right thing. So can you tell what's wrong here?
Be more specific, please.
Well, they're sorry.
Which thing is wrong?
Hey, you know, on Jeopardy.
I'm guessing this is a this is a foam sheathing where they're trying to make where they're installing it as the air and water barrier, and they're using a lateral tie, probably for masonry, that where the red circle is, it's missing whatever tape they put on there as a gasket, but also typically these attachments have a prong that goes through the foam back to the stud for structural attachment, which is also another hole. But I'm not sure that foil tape is going to allow for gasketing.
Yep.
That's my stat.
Yeah, so also looks like some mixing and matching of systems and products, and which is always kind of Wild West, because then, you know, we rely on the manufacturers. You guys are the experts in your systems, and we can't go to you and say like, hey, what do you recommend for this arrangement of products that aren't yours and have never been tested by anybody before? So that's always a little bit shady to kind of mix and match like that. I love that Keith had talked about blind fastening earlier, and now here's a great example of it. Your water resistive barrier, air barrier membrane is behind this sheathing, behind the insulation, so you can't see it. So these fasteners are penetrating that membrane, and it's called blind fastening because we don't know what we're doing to it. So does that mean that's always a problem? No, not necessarily. It could be low rise, wood framed, you know, a really thick membrane. You might be just fine, but as that risk goes up, you're going into high rise, you're going into metal frame, you're going into gypsum sheathing. All of these things, risk factors start creeping up, and we really don't recommend blind fastening. It's a risky way to go.
Well, and this is, this is also a mixing of trade partners too, where you have your air and water barrier, potentially your insulation installer, separate from your masonry contract, and they're using different systems, different products, and they're not being coordinated between. So if there is a WRB behind the foam plastic, and the foam plastic isn't intended to be that primary air and water control, then there seems to be some coordination missing between the various trade partners as well.
We like to do training for our installers. It's like the do's and don'ts, right? And we tend to have no one usually takes a picture of like, that's a good installation, I'll take a picture of that. Don'ts, pictures of the don'ts. But seriously, for those of you that are watching today, if you have some interesting don'ts that you want to share, please send them in, because I would love to be able to gather them and share them with everybody. It just helps us all in terms of looking at it. I think we did like, you know, what's wrong with this picture for one of our trainings too. You know, you had to count like the 8 different things that were wrong in this picture. So it's definitely helpful from an education perspective. So just to wrap it up here, you know, choosing the air barrier system for your project, right? So I think we all mentioned that today. You know, what's going to work best? What is the performance required? You know, if it's, you know, a 1-story building versus a 12-story building versus being on a coastline. There's a variety of things that we can do at that material level to get an understanding. whether it's the smooth roofing nail or the threaded fastener, taking it to that assembly, that mock-up and on-site. So final thoughts, Keith. We'll start with Keith Simon.
Sure. So I think just recommendations for what folks should do when they encounter this on their next project. You know, the ideal scenario is that you do testing of your exact configuration, right? Your specific assembly attachments and everything. And for, like we were discussing, for both air and water, we want to test both of those. So that's kind of ideal. Next best is rely on the manufacturer. So follow the manufacturer's recommendations and requirements. And sometimes those aren't the same thing. Sometimes a manufacturer has requirements, and then to upgrade, they have recommendations. So you really want to follow the recommendations if at all possible. And then kind of third best after that is to follow generally good rules of thumb, like increasing the thickness of the membrane, detailing like sealant behind the cladding attachment and at the top edge. So general good practices like that. But you know, good, better, best. Good can be pretty darn good if a lot of times we don't get any of those things. So.
Keith Nelson.
Yeah, all great points. I would add to that in understanding what you're getting, but understanding what you need. I mean, what is required for the project. There's not a silver bullet Cadillac answer that serves every project, especially when you consider schedule and budget and other kind of performance factors that may not be related to air and water. We need to understand that and dial it in and get the performance requirements correct. And I like that you list materials and assembly. What we are missing there is whole building, especially when we're talking about air leakage is a critical factor and something to be discussed. And then lastly, I would just say, you know, we talk about testing, whether it's lab testing or field testing, but where I see the most value on projects is the ability to do performance mock-ups on site, off the building, before you do the install, to do all your learning on this mock-up with details that are anticipated for the project. So if there are changes that need to be made, we're making them before we're constructing the building in 20% complete or worse. So on-site, off-building performance mock-ups and using them as learning tools is absolutely key.
That's great. Great comments there. Guys, Keith Simon, Keith Nelson, thank you so much for being a part of this today. I'm sure we're going to get a lot of comments and questions, so maybe we'll do round 2 and focus on air as well in the future. So thanks, guys, for being able to be a part of this today.
Thanks, Marcy. Thanks, Paul, and thank you, Keith.
Thank you all for having me.
Awesome. Well, Paul, that wraps up the month of June.
I liked, we heard whole building.
Yeah.
So we need to definitely have a session on whole building. That's a great topic.
We definitely should, and maybe we offer up this building because it went through some renovation in the past. I think we are at our 10-year mark of renovation.
Yeah, we have a heck of a before and after.
Yeah.
Before was leaky sieve.
Yeah.
From the 60s.
Yes.
After is pretty darn good.
Yeah. So I know, I think it was last August, we featured this building and the work that we did because we were on our 10-year of renovation. So it'd be interesting to kind of take a look back at that and do some whole building testing.
Yeah, we had some very aggressive objectives and we met those, and we live in this building every day.
Yeah. Awesome. So thank you again, everyone, for joining us today and in the month of June. As always, if you missed any of them, they can be found just by looking at Tremco CPG Live, and you'll get the whole suite of episodes. I think we're on 57.
A lot.
Yes, a lot.
A lot.
Okay. Thanks, everybody. Have a great weekend.
Thanks. Be safe.